We're going to talk about continue talking about the basic data types and operations. So now we're going to talk about these two categories, the set types and the mapping types. But before that, we need to understand the concept of a hash function. So the concept of a hash function is just a function that takes any object of any data type and of any size and comes up with some representation of that object that is always consistent. So that's what we call the hash sum. So the output of the hash function is a hash sum, which is a representation of the input object. But all the hash sum are of fixed size, so they are just pretty much consistent. Okay. So we're turning something that is variable in size and type into something that is fixed in size and type. Okay, and it has very common a lot of usage. One of the common use cases that in which you use the hash is to create a hash table. So let's say we have a table here. This is a table that has names and phone numbers. We already know the concept of a numeric-based index, so the number-based index, right? So when we start with 0, 1, 2, then every row has an index. Now, if you remember from the data structures and algorithms course, if you try to find a row or an element using an index, what is the time complexity of that? It would be O of 1, right? It's constant, right? But if you try to search by something like a name or a phone number, that means that you're gonna have to compare the name that you're searching for with every single name in the table or in the list until you find it. So what is the complexity of that? That would be O of n, right? Now, if we know that it is common that we search by name, then we can create another index other than the numeric based index that is another index that is based on the hash of that object. Okay, so we take that object, send it to the hash function, take the hash sum, and use the hash sum as the index. Okay, so in that case, instead of finding an object by name in an O of n complexity, we can find it in an O of 1, a constant, just like a number. Okay, now the hash table like implementation in Python is something called a dictionary. We're going to talk about it in a bit. But this is one of the common usage of the hash function. Okay, now let's have a look. How does it look like? So if I find the Python interpreter here. Okay. So let's say the function that it creates the hash in Python is called hash. All right, and it takes something, anything, any object that can be hashed, like a string, for example. So an object that can be hashed is we call a hashable object. Hashable. So we can send any object to the hash function as long as it is hashable. And so far, what we know, the type of the object that we know they are hashable are the immutable objects. So immutable objects are hashable. Mutable objects are not hashable. Okay, so you can create a hash sum for an immutable object. Now the string is an immutable object, so therefore we were able to send it to the hash. Like what if I try to create a hash for a list? And we know that the list is mutable, right? So in that case, it will give me an error. Tell me this is not immutable. It's unhashable. Okay. Now, what if I want to create a hash sum for a set for a list? In that case, I have to turn it into a tuple. We know that the tuple is immutable, and that's why we have another type that is very similar to the list, but instead of square brackets, we have round parentheses. That is the tuple. So the tuple itself is immutable, so therefore it is hashable. So we can send it to the hash function and create a hash out of it. Okay? So whenever we send an object to the hash function, it gives us a hash sum. And in Python, we have to send something that is hashable. And the ones that we know so far that are hashable are what we call the immutable object. Okay, so we can send an immutable object, and it should be consistent too. So if I send the same object, it should give me, generally speaking, should give me the same hash function. All right, so what if I have something like this, like a bigger string? So it should be of like similar size. If you remove the negative sign, it should be of similar size, okay, to uh, the other hashes. Okay. All right. So next we're gonna see how these hashable objects or these immutable objects and these hashable objects are used in the sets and eventually in the dictionaries.